Oh, wow. Okay, so this is incredible, especially because the model is running entirely locally. Okay, so DeepSeek is out with the official version of V4 Flash, and this one is special. It actually beats the previous V4 Pro on a number of benchmarks and surpasses much larger models. Now, it sits at the Pareto frontier of cost and efficiency. And keep in mind, all of this is thanks to post-training. It's not a new model or a new architecture. Now, we do want to look at some benchmarks. These are the official benchmarks that are released by DeepSeek. But the beauty is that you can run this entirely locally. So what you're seeing right now is actually running on a 2 DGX Sparks setup at a pretty reasonable speed. More on that later in the video. Okay, so the benchmark results that they shared are kind of shocking. So this is the DeepSeek V4 Flash. And then we have the previous V4 Flash preview. Now, specifically for agentic coding, a lot of people pay attention to this DeepSeek benchmark, which was only 7%. But now with this new update, it jumped all the way to 54%, which is crazy. Now, keep in mind, it's not all about the model, something else going on as well. And we're going to talk about that in a minute. Now, on the benchmarks, the most important thing here is that it actually beats GLM 5.2 on almost every benchmark, which is almost a 3x larger model. So this shows that there is a lot of efficiency and performance you can extract from these smaller models with further post-training. Essentially, it's getting really close to Opus 4.8. And keep in mind, it's just a 284 billion parameter. So it's a fraction of the size of something like Opus 4.8. Okay, the benchmarks are impressive. However, this is not apples to apples comparison. In fact, if you go and look at here, they actually tested it specifically for the agent. Now, for code agent tasks, they actually tested these benchmarks under the DeepSeek harness, which is coming up next. So the other models may not have been tested because I don't think they had access to the DeepSeek harness. So this is a big factor that you see the improvement. It's not just about the model, it's all about the harness around it. Now, a good example of how much impact a good harness can have on the benchmarks results is the recent study from OpenAI, where they compared the official harness under which the benchmark runs for ArcAG versus their optimized harness. And you can see that the score went from almost 13% to 40%. We're looking at 3x better performance, right? So you need to actually think about the harness that is being used when you're looking at the benchmarks. A lot of benchmarks forces you to use their own harnesses, which are not optimized for the models. So there is a lot of performance you're leaving on the table if you're using an unoptimized harness. If you want to learn more about how to build better harnesses, I'll put a link to a video in the description on designing long-running harnesses. Now, out of all of these benchmarks, I think the most interesting ones are at the bottom. So DS Bench Full Stack and DS Bench Hard. These are internal DIC benchmarks, which are not available to general public, but it's really interesting to see how much performance gain they get out of this new model on their own internal benchmarks. And usually companies care more about their internal benchmarks than the external benchmarks because they make sure that the internal benchmarks are not contaminated in the training data, because that's the only objective measure of the model improvement. So on those two benchmarks, it just lags behind Opus 4.8. Okay, so the artificial intelligence index actually has an even better story. So this was a huge jump, and right now it's sitting right next to Gemini 3.6 Flash, which was released just a few days ago. So it's really at the frontier when it comes to a workhorse model, especially the price point at which DeepSeek is providing this. Pricing wise, we are looking at about 2 cents per million input token And then only 30 cents or close to 30 cents per million output token, right? It's really hard to beat at this price. But even better than that price, you can actually run this model locally if you have a couple of DGX Sparks. And it can run at almost 30 tokens per second unopt. I just loaded this on 2 DGX Sparks in NVFP4, and it seems to run pretty nicely. Okay, I'll show you some of my local results in a minute, but these are some results that shared on X. Link to this is going to be in the video description. Now, right now, it's all about token efficiency and cost. So OpenAI yesterday substantially reduced the price of their GPT 5.6 Luna and Terra, and they were really at the Pareto frontier of cost versus efficiency or performance. But now with DeepSeek, I think they are at the Pareto frontier. So this is the artificial intelligence index versus cost per intelligence index tasks. And on this, when it comes to the intelligence versus cost ratio, DeepSeek V4 Flash July 31 edition is unmatched. Now, cost is becoming a big factor, and a lot of companies are actively trying to ensure that they reduce the token cost. So having options like this is going to be extremely important. Okay, so when it comes to agentic coding, where this model actually shines, a lot of people are currently interested in the Terminal Bench 2.1. It gets really comparable score to some of the best models out there at a pretty reasonable cost, at a fraction of what these other models actually charge you. Okay, next I'm going to show you how to test this. So they have added support for responses API, so you can directly use this in Codex, but I want to use an open harness. So we're going to be running this in open code. I am running it locally on 2 DGX Sparks, DB1010. Thanks to NVIDIA for providing me with the compute. I just connected both of them into a small cluster. There's a video going to be coming up on how I am doing it, but so far I'm actually really enjoying the experience. Okay, so for this quick test, I'm going to run one of my previous example prompt that I used with the web version initial Flash. So this is basically asking me to create an encyclopedia of the first 25 legendary Pokemon, but I want to test it in Agentic Harness. So this is also going to give you a sense of what exactly the speed actually looks like. Okay, so the speed is actually pretty decent. I am getting about 25 tokens per second. And right now it's just thinking through. The chain of thought is actually pretty coherent. I don't really see a lot of weight that used to happen in the initial version of DeepSeek models. It used to be a lot more verbose, but now it seems to be a lot more well structured. Now, while that is happening, we're going to run another command where we are basically asking create a tracker for the International Space Center. We provided the API reference where it can get the data, but it has to basically create the whole UI around it. We're going to see how good both of these outputs are in a minute. Okay, so within the open code harness, we actually see how much context it has used so far. It keeps tracks of the to-do list of what different actions it has taken so far, what it has still to do, right? So it gives you a really detailed overview of what exactly the agent is doing. So far, I haven't really seen any mistakes. Now, it seems like the first output is actually ready. This is the legendary Pokemon Encyclopedia. Now, the UI could definitely use some work, but seems like it's fully functional, which is pretty good, right? Keep in mind, it's a workhorse model. It's not state-of-the-art frontier level model. This is supposed to be used specifically for agentic coding tasks, or as an executor, you do planning with a much bigger model. But I so far like the experience. Okay, so for that Pokemon side, it used about 19,000 tokens of percent of the whole context window. The supported context window is up to 1 million tokens. Now, one of the biggest problem with DeepSeek models are that they are text only, so no multimodal image or vision support yet. If you want fully multimodal inputs, in a model, I would highly recommend to look at Inkling Small. Also running the same model on the 2 DGX Sparks setup, getting about 20 to 30 tokens per second, depending on how many streams I'm running. There's going to be a video on that coming out pretty soon. So if you're interested in local setup, make sure to subscribe to the channel. And that model actually is really good. It's not as good as the DeepSeek V4 Flash on the benchmarks, but being a multimodal model is pretty incredible. And the best part is that it natively processes audio. So you can create chatbots which you can interact with in almost real time, and it will understand your audio without needing any external text to speech or speech to text system, which is pretty awesome. So I'm putting together a video on how I'm doing it. Okay, so what exactly is the type of hardware you will actually need in order to run this? So that really depends on the quant level. For example, if you are trying to run this in 4-bit precision, you need about 168 gigabytes of VRAM, which means you probably need 2 DGX Sparks. Each one of them has effectively 115 gigabytes of usable VRAM, or another system that has more than 108 gigabytes VRAM. Keep in mind that VRAM is only for model loading. If you want to use the full context or any usable context, usually you need a lot more. Similarly, in 3-bit quantization, you would need 110 gigabytes of VRAM. Now, there is a way around it. So previously I created a video on Dwarf Star, which is a custom engine specifically designed for DeepSeek models, and they recently added support for GLM 5.2, is by the creator of Redis, right? So using some really interesting tricks to SSD offloading, manipulation of KV cache, and then using some really interesting setup around mixed precision, where not all of the weights are loaded in 2 bits. Some of them are kept in 4 bits. More specifically, NVPF. They're able to run it at a really reasonable speed on a system with 128 gigabytes of VRAM, and you still have a lot more useful memory left for KV cache. I'm going to put a link to that specific video, which really explains the whole Dwarf Star 4. Highly recommend to check it out if you are interested in running this. Since it's exactly the same architecture, it's just weight updates, so the same setup is going to work when the weights are updated. Oh wow, okay, so this is incredible, especially because the model is running entirely locally. This was after a little bit of back and forth. Rendering is pretty awesome, and it added these stars in the background, which is pretty nice, right? Now, this is supposed to be the current location, which I don't think is right, because currently it's just over North America. So this is the real position, right? But I think we can tweak the API call a little bit to get that right. But overall, the rendering quality is pretty awesome, especially if you can run this model entirely locally on your own hardware. I'm kind of impressed. Now, you can also use the DeepSeek model through the API. Pricing is pretty incredible at the Pareto frontier when it comes to intelligence versus cost. But do let me know how your experience with this model is. Link is going to be in the video description. And if you're interested in the local setup, also let me know. I am going to create a follow-up video. Anyways, I hope you found this video useful. Thanks for watching. And as always, see you in the next one.